Good afternoon, students. Let's start with the topic signals. You can see signal is a mathematical representation of physical phenomena which contains some information. Now, what is physical phenomena? Like AC voltage signal, we can represent it as xt equals to A sine omega naught t. Here A is the amplitude and what is omega naught? Omega naught is the fundamental frequency. And this representation is the mathematical representation. Okay, so we have defined signal. So what are some example of signals? Like noise signal, audio signal, video signal, etc. Now, as we know what is signal, now see what is function. A function is a dependent variable which depends upon one or more independent variable. Important part is dependent variable, which depends upon one or more independent variable. Suppose xt is a function. So what is the dependent variable here? It is xt. And what is the independent variable here? It is t. Here, as t changes, xt will also change. That's why xt is the dependent variable here. It is the here the dependent variable is xt and independent variable is t. So there is only one independent variable, which is t. If we have a function which have two independent variables, let's x t comma lambda. Here the dependent variable is xt comma lambda, and the independent variable is t and lambda both. Mathematically, signal can be represented by a function which contains different values at each time instant. Let's see, if we have a function xt which is look like this. So can you tell me what is xt? It is x square, you know that, parabolic function. Here for a particular time instant it has two values. This time instant, this and so on. So is it a function? Yes, it's a function, but it is not a signal. Let's take another example. We have this. It is a straight line. So for a particular time instant, it has a single value. So is it a function? Yes. And is it a signal? It's also yes. Because for a particular time instant, it has just one value. Let's take another example. If we have like this, for a particular time instant, make sure that it is that in time axis is here, and if we see that this time instant it has one value, this time instance it has another value, and this also another one. So of course it is a function, and it is a signal also. Okay. Now let's see what type of signals we have based on the variables. Xt, a dependent variable is xt, independent variable is t, and what type of signal is this? It is a time domain signal. If we have x lambda, so can you tell me what is the dependent variable? It is x lambda. Independent variable, tell me, it is lambda. And what type of signal is this? It is a random variable. Here lambda is the space. Another one is xf or x omega. Here dependent variable is xf or x omega. I think you can not see this. Independent variable is f, sorry, it is small f. It is small f means frequency. Either it is small f, which is the linear frequency, a more accurate term, or omega, which is angular frequency. Next is, what type of signal is this? It is a frequency domain signal. I have write it in short form. Another type is x t comma lambda. T is time and lambda is space. Here, the dependent variable is, tell me, it is xt comma lambda. Tell me the independent variables. Here, the two independent variables are time and space. So, what type of signal is this? It is random signal or random process. So we have seen four types of signals here. First is xt, x lambda, x f or x omega, and x t comma lambda. Let's revise this. What type of signal is this? It is a time domain signal. What is this? It is random variable. This is a frequency domain signal. And at the end, it is random signal or random process. Fine. We studied all this. Wait a second. Now let's move to the types of signals. Previously, we have studied based on the variables. Now it is there are many signal, but we will study only those types which are continuous and discrete time signal, Then time and frequency domain signal. We have already studied this. Now let's see some examples of time domain and frequency domain signals. Time domain and frequency domain. We have already seen the example of time domain signal in the uh, in first, which is AC voltage. And frequency domain signals are voice signal whose range is 600 Hz to 3.5 kilohertz. Audio signal 20 Hz to 20 kilohertz. Video signal 0 to 4.5 megahertz. In the next lecture, we will know about the continuous and discrete time signals. Thank you.